Hey guys, this is Sarang from Skill-Lync. If any one of you is from Tibet or have been there, you would know that Tibetans essentially drink their tea while it is still boiling. For most of us, that might sound dangerous, right? Actually not. You see, although the tea is still boiling, the temperature of the tea is at a drinkable level. This is because the country of Tibet is located at a high altitude from the sea. Hence, the atmospheric pressure is low enough that the boiling point of water falls down. As you all know, at sea level, the boiling point of water is about 100 degrees Celsius. But in Tibet, water starts boiling at lower temperatures, and that is why it is safe. Speaking on how boiling points vary due to pressure, there is a similar phenomenon happening in engines, which is technically called as cavitation. In this video, we will be discussing how cavitation occurs using a simple example. If you take an engine, the fuel flows in a complex path from the tank to the combustion chamber. During this time, the fuel flows through chambers that vary in curvature, area, and etc. When fuel flows through chambers where the area suddenly decreases, it would result in reduced static pressure. If I could take an example, let us consider the winkle of a nozzle. Now, the winkle of a nozzle is a benchmark nozzle which is commonly used to study flow-related phenomena. So, anyone who wants to perform CFD or study cavitation in an engine nozzle would choose the winkle of a nozzle. In this nozzle, the fuel passes from the fuel chamber into the throat of the nozzle before it is sprayed out through the outlet. Now, the fuel chamber has a large area compared to the throat of the nozzle. When fuel flows from the chamber to the throat, some of the fuel gets separated from the wall. So in this separation gap, there is a drop in static pressure. Now when this pressure drops lower than the vapor pressure of the fuel, the boiling point of the fuel naturally drops. So it will start boiling and vaporize. This is similar to how tea boils in Tibet at low temperatures. In Tibet, the atmospheric pressure is low, hence water starts boiling at lower temperatures. Similarly, in a winkle of a nozzle, the static pressure inside the nozzle falls lower than the vapor pressure of the fuel, and hence the fuel starts boiling and vaporizing. In Skill-Lync, we decided to simulate fuel flow through a winkle of a nozzle using Converge CFD software. Cavitation is a multi-phase flow problem. That is, it has both liquid and gas phase. In order to run such a simulation, the volume of fluid methodology was used. After setting up the boundary conditions, turbulence model, and volume of fluid solver, we ran the simulation, and here are some results. In this animation, you can see that we have obtained a velocity contour of the fuel flow inside the nozzle. From the contour, you can see that the velocity is maximum at the throat. This is because when the fuel enters the throat, the sudden contraction of the area causes the pressure levels to drop critically. Like I explained earlier, as the static pressure drops below the vapor pressure of the fuel, cavitation occurs, and some of the fuel cavitates and creates pockets of fuel vapor. Cavitation can affect your equipment in several ways. When fuel cavitates in a nozzle, it affects the fuel mass flow rate. This can further affect the combustion and emission performance. In HVAC or turbo-machinery world, it is important to study cavitation in rotating devices. For example, in centrifugal pumps, the impeller rotates at a very high speed, due to which a low pressure zone is created. This can lead to cavitation. The fluid in this low pressure zone vaporizes to create air pockets, which can hit the component and cause damage on the impeller and the wall nut. This will result in decreased life of these components. If you guys are working or studying in a field related to automotive engineering, it is important to be familiar with the topic of cavitation. To learn more on this subject, you can sign up for our HVAC Systems Flow Analysis course. The links are in the description box below. Hope you guys found this video informative. See you in the next video. Bye.